Hello everyone, welcome back. This is lesson 4 of the 6th unit of Math 10C. Unit 6 covers relations, equations, and graphs. I didn't type up the page number here. Let me just look. This is on page 13 of your unit handout. We're going to be looking today at special types of relations called functions. And there's two things that you need to get out of this lesson. One is how to determine if a relation is a function. And the second thing is how to use what's called function notation. So to begin with, before I even tell you what a function is, I just want you to understand that a function is a type of relation. Much in the same way that a chicken is a type of bird. So when we take a look at a collection of birds, some of them are chickens and some of them are not. When we take a look at a collection of relations, some of those relations will happen to be functions, but not all of them will be functions. So a function is a very special type of relation. Well, let's get into what the special feature is that makes a relation a function. First of all, when you make the table of values for a relation, you almost always choose the value for x and put those values of x into the equation and figure out what we get for the y value. That's almost always what we do. You put x in and you get y coming out. Because of this, we sometimes call the independent variable, which is x, the input, and the dependent variable, which is y, we call the output. You can think of a relation as being this machine that takes an input, does something to it, and spits out the output. For example, if I put the number 3 into this relation and I get the number 7 out, that means the input is 3 and the output is 7, and that means that 3, 7 would be a point on the relation. Okay, this is nothing new. It's just a new way of looking at it. If I take the same relation and I decide to input a value of 5, and the relation does something to that 5 and gives me the number 11, then that means that 5, 11 is a point on the relation. You can try it with a third one. If I put the number -4 in, and the relation does something to it, and it spits out -7, then that means that -4, -7 is a point on the relation. And really, if you're good with numbers, you might pause the video here and ask yourself, what is this relation doing to the input to get the output? So if you want to try to crack the code here, this relation is doing the same thing to x every time to get y. Go ahead and pause the video, and when you're done and you figured it out, come back. It turns out that what's happening is the relation is taking x, it's doubling it and adding 1. So if you take 3 and double 3 and add 1, you get 7. Doubling 5 gives you 10, adding 1 gives you 11. Doubling -4 gives you -8, plus 1 is -7. So that's an example of what a relation is doing. Now let me tell you what a function is. And this thing that we just looked at happens to be a function. A function is a relation that always gives one output for each input. And you're probably going to sit there and think about that and go, how could it be any other way? We'll get to an example in a second. But what this is saying is, if you have a relation where you put in a value of x and you always, no matter what value of x you put in, you get a single value of y coming out, then it's a function. If, however, you put in a particular value of x into the relation, and what happens is the relation doesn't tell you that y equals a specific number, but it tells you y can be more than one number, then that relation is not a function. So in order for a relation to be a function, every x value must give you only one y value. We'll take a look at another relation here. If I throw 9 into this relation, I get 3. If I throw 25 into this relation, I get 5. And many of you will, you think, know what the relation is. You're probably going to be wrong. I hate to break it to you. If I put 16 in, I get 4. Now comes the surprise. Sometimes when I put 9 in, I don't get 3, I get negative 3. And when I put 25 or 16 rather in, I can get negative 4. So here are the ordered pairs that this relation is creating. And you'll see something that when I put 9 in, which is a single value of x, I get 2 outputs that are different. So you put 9 in, you don't get just one output, you get 2. You get 3 or negative 3. The equation of this relation, which is not a function because of this property, is y squared is equal to x. If you take, for any of these, the x-coordinate and the y-coordinate that's shown in each individual diagram and put it into this equation, it will be true. Y squared equals x is not a function, because a number like 16 for x gives you positive 4 or negative 4 at different times. So, which of the following are functions? Well, I put in 11, I get 3. I put in 21, I get 3. I put in 31, I get 3. I'm not getting multiple outputs that are different for the same x-coordinate. Let me show this to you graphically. When I put in x equals 11, I get y equals 3. I don't get y equals 3 and y equals some other number. I just get y equals 3. When I put in 21, I get 3. When I put 21 in for x, I get one and only one output for y. So it's a function. So this is a function. Let's look at B. When I put in 6, I get 10. And when I put in 6, I also get 15. And we don't need a graph to understand this, but I'm going to put this in anyway. So we'll say this is 5, this is 10, this is 15, this is 20, and we'll say 6 is over here and 7 is over here. So when I put 6 in, I get 10. When I put 6 in, I get 15. And when I put 7 in, I get 20. Well, these 2 points here have a single x, which is 6, producing kind of a branched output. It produces 2 different y's, 10 and 15. If you think of this in terms of that machine model, this is saying when I dump 6 in here, it spits out 15 and it spits out 10. Because we get multiple outputs for a single input, this is not a function. Let's take a look at the next one. 5 produces 10, 6 produces 15, 7 produces 20, definitely a function. When you use a single x like 5, you get one and only one y, which happens to be 10. And the same can be said of a single x of 6 being used or a single x of 7 being used. When we have, and it might help for some of you to make a table of values here, When we have 1, we get 2. When we have 2, we get 3. When we have 3, we get 4. For every value of x we choose, we only get one value of y. You don't get multiple values of y for a single x, which means this is a function. This, on the other hand, is not, because when we use x equals 1, we get 1 or 2 or 3. So this is not a function. When you have a graph, and I actually want to go back to A and B here. Well, we'll talk about B. This is not a function. And I want you to notice that the only way you can have multiple different values of y with one single value of x is if you can draw a vertical line that passes through more than one point. The fact that this vertical line, and I'm just going to adjust it because it's not nice and square, the fact that this vertical line is at x equals 6 and it passes through two different points means that for that one value of x, there's one x here, you get multiple y's. And this is what we call the vertical line test, everybody. If you can draw a vertical line somewhere on the graph, and that vertical line crosses the graph in more than one place at a single location, it is not a function. And I'm going to start off with h. Right here, I don't know what x value that is. Let's just make up a number. Let's say that that is x is equal to 2. This is x equals 2. Well, there's a point here with a certain y coordinate. There's a point here with a different y coordinate. There's one here with a different y coordinate. There's one here with a different y coordinate. The vertical line crosses this graph at this location in more than one place. And that means this is not a function because we're getting more than one y coordinate. So no to that test, not a function. If I take my vertical line and I put it over here on A, no matter where I am, here, 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 at any particular location, I will always only cross the graph in one place. It is going to be a function. Same with this one. So both f and g are functions. One of the things we learned a couple of lessons ago is that if you have a degree 1, which we do here in I, the degree is the exponent on the x variable, that this is linear. So this will be a linear graph. We can even graph it if we want. We're getting a little bit more practice using our graphing calculator. 2x minus 5, I'm just going to y equals. And if you were ever graphing what I would call a pure equation, which means there's no context. It's not about selling hot dogs or wedding parties or anything like that. It's always a good idea to go to your zoom menu and choose zoom standard, which is zoom 6. This is a linear function. This is going to pass the vertical line test. It will be a function. Because of the y squared, This is not a function. This has nothing to do with degree. It's simply a special relation that you've already seen today, where I can have something like, for x, I can have 16, and it can give me 4, or it can give me -4. Because as long as y squared gives me x, it doesn't matter. And when you square -4, you get 16. When you square +4, you get 16. So that's the first part of this lesson, using the definition of what a function is to determine if a relation is a function. The second part is function notation, and this is a little bit different. You're going to get lots of practice over the coming units with this, and also in your grade 11 math, particularly if you go on to -1. So function notation is just a special way to write relations that are functions. It's just a type of notation. You use symbols like this. There's an F and a brackets and an X. And that set of brackets does not mean multiply. It just means that it's a function. And we'll get into the nuts and bolts of it right away. We read that as f of x. So from now on, whenever you see this, you say f of x. And it means that what you're about to equate it to is a function of some variable called x. It just means that the thing you're going to calculate is determined by whatever x has for a value. And I'm going to maybe get ahead of myself here, but if I tell you that f of x is 3x, I'm just telling you that every time you calculate the value of this function, all you do is you triple x. So the function is 3x. And I can lead up now to this idea. If you are truly bothered by that notation at any point, you can always replace the f of x with y, because that's really all it means. Well, that's all it means at this level. It's going to get more and more involved and meaningful to put f of x rather than y. But if it really bothers you, just put y. If the variable is a letter other than y, then you can still use function notation. There's the formula for area of a circle. If you want to determine the area of a circle from the radius, you take pi times the radius squared. So area is a function of the radius. Like, I'm going to repeat that and ask you to think of that sentence. Area is a function of the radius. It simply means the area is some measurement that's determined by the radius. It's a function of it. And for that reason, we could write it that way. These two things mean the exact same thing, but the one on the right is read as area as a function of radius. A of r is equal to pi r squared. If I told you that the cost to host a banquet was $500 plus $20 times the number of people, because that's how much it costs to feed them per person, then we would say that cost depends on the number of people, and we could say cost is a function of the number of people. So we could say C of n, or cost as a function of number of people, is equal to 500 plus 20n. Many students, myself included when I first saw this, had the question rolling around in their head, why? Why bother with this? And the best I can tell you right now is by the time you get to higher levels of math, particularly 20-1 and 30-1, but -2 as well to some degree, you cannot do the math without using function notation. And that's why we like to introduce it to you early in grade 10. Example number 1. In the early day of cell phones and texting, bills were based on the number of text messages sent or received. When companies started saying you had unlimited texting, that was a big thing, because prior to that you had to pay every time you sent a text. So there was a cell phone plan in 1998 that a person by the name of Sky had, and she had a monthly fee of $20 plus 15 cents for each text sent or received. And her monthly bill could be modeled by this formula. And I hope that you see how 0.15n plus 20 comes out because of the $20 plus 15 cents per text. N is the number of text messages, C is the total charge, A, write the function or the relation in function notation. Well, we're just going to write C of n equals 0.15n plus 20. And I'll tell you right now that there's absolutely zero difference between the meaning of this and the meaning of what's highlighted in yellow. They mean the exact same thing. So now, what is the meaning of C of 10? And that's how we pronounce that. And I'm going to write it right here, C of 10. Well, we can read it as meaning it's the cost of, or the charge for, 10 text messages. But I want you to notice something, everybody. I'm going to get rid of my blue highlighting here. I want you to notice that what I have done is I've changed this n to the number 10. And I've purposefully written C of 10 directly below C of n for that reason. And all that means is I need to put a 10 here as well. So C of 10 will be 0.15 times 10 plus 20. You guys can grab your calculators and work out what that is. It's going to be $21.50. So what is the meaning of C of 10? The meaning is this. If we make a table of values, when I put 10 in here, the y coordinate is C of 10. Or when I put 10 in here, I get 2150. This is the y coordinate when x equals 10. Now I realize there's no y's and x's in this question. I get that. I could say it's the c coordinate when x or when n is 10, but I'd rather talk about y and x, and I think you get my drift. If Sky's cell phone bill for a certain month was $22.25, how many text messages were there? Listen, even though we're talking about function notation, when we're answering questions like this, there's no need to use the function notation. This is simply saying, if the charge is $22.25, what is the value of n? So we're going to put $22.25 in here. And we're going to solve this equation, which I would describe to you as being a two-step junior high equation. Let me give myself another couple of spaces here. You're going to start by subtracting 20 from both sides. Get a new equation, which is $2.25 equals 0.15n. Then we can divide both sides by 0.15. Of course, what's going to happen is we get that canceling, and we are left with n is equal to 2.25 divided by 0.15 gives me 15. So the answer is 15 text messages. We're going to learn how to use some more features of our graphing calculator now. We're going to make a table of values, and we're going to graph the function for up to 400 text messages. So I'm going to go to my y equals and enter the function c equals 0.15x plus 20. So y equals 0.15 x plus 20. I'm interchanging x with n and y with c. So that's the function. We want to make a table of values and show a graph for up to 400 text messages. So we're going to do something that we did yesterday with a different question. We're going to go to our window setting, and we're going to go from 0 to 400 for x, and we can go up in increments of, we'll say, 50. Now, what we need to do is generate a table. We'll come back to the graph in a second. But if you take a look at, I'll highlight it for you so you can see this because you can't see me pointing. Your window key, the word right above window says table set. And that's what I would like us to go into. So rather than just hitting window, you're going to go second window. I can get this thing erased and going. There we go. Second window. And this is what you'll be looking at. Now, you might have different settings on your calculator, but regardless, I would like us to start at 0. So we want to make sure it says table start 0. The delta table, that's what that triangular kind of thing means, is delta, is it's how much we want to go up in our table by. So let's just leave it at 1 and make sure that it's automatic for everything else. And now what I would like you to do is notice that when you look at the graph key, the word above graph is table. And that word on my calculator is in blue. So I'm going to hit the blue key, which is the second key, and then table. And there is my automatically generated table. On the left-hand column is all of the different numbers of texts. And on the right-hand column are all of the charges for the month. Now, if we want to generate a table up to 400, go back to your table setup, second window, and start at 0. But now instead of having delta table equals 1, you can put delta table equals maybe 50. And go back to your table. And you will see that it is showing for 50, 100, 150 texts, 200, 250, 300, 350, 400. So this is our table. Quite frankly, I don't care if you write down this entire table. I'm trying to show you how we can use the graphing calculator to create a table. It's a very important skill. It's not a one-time only thing. We're not just doing this now. We're going to do it later for other examples. The nice thing about that, too, is now I can see what my y coordinate is when I get up to 400. It's $80. So I'll remind you, we put in for y1 the formula. We went to our window and went 0 to 400. For x, that tells us now we're going to go from 0 to, it was $80. Let's go up to 80. I'm going to show chunks of 20 on my graph. So when you hit the window key, you're looking at this and you're setting up the parameters for your graph. When you go second window, you're looking at this and you're setting up the parameters for your table. So my window is all set up. I hit graph. There's the graph. We'll work with graphs and graphing calculators more and more when the opportunity arises. Take a look at example 2. Given f of x equals 4x plus 5, what's the following? Well, f of 0 is simply going to be 4 times 0 plus 5. F of 0, I'll put it on the side, but I'm not going to do this for all of them. If we have f of x, which is really the y coordinate, and we have x, when I put 0 in here, f of 0 simply means the y coordinate. So you're replacing x with 0 to calculate what y is. If that troubles you, well, then rewrite this as y equals 4x plus 5. Bottom line, you're going to put 0 in for x, calculate what you get. What's f of negative 2? We're going to put negative 2 in for x and calculate what you get. And I'll leave it to you to use your calculator in your brain to figure out that that's negative 3. F of 6 will be 4 times 6 plus 5, which I think is 29. F of 100 is 4 times 100 plus 5, which is 405. F of q is 4 times q plus 5. Don't psych yourself out and twist your brain into knots trying to figure out what f of q means. F of q is a mathematical expression that I'm asking you to find to build your algebra skills and your mathematics skills in high school math. Similarly, what's f of puppy? 4 puppy plus 5. It's not always going to be a number you're putting in for the x coordinate. All right, I think I have one last example here. A function is defined by h of x equals 2x minus 20. Solve the equation 60 equals h of x. Well, if I have 60 equals h of x, and I'm telling you that h of x is equal to 2x minus 20, well, then these two things are equal. And that just simply means that h of x is 60 and h of x is 2x minus 20. That must mean 60 equals 2x minus 20. Another basic junior high question, we can add 20 to both sides and get 80 equals 2x. Divide both sides by 2. Get x equals 80 over 2, which is 40. And that's the answer to example 3. Two sides to this lesson. One was identifying whether a function, one was identifying whether a relation is a function, and you can use the vertical line test for a graph, but remember, a function is a relation where for each x coordinate going in, you get one and only one y coordinate coming out. And the other side of this lesson had to do with function notation. So on page 311, questions 1 through 8 are the recommended practice problems. As I said in the previous lesson, we are closing in this week on getting ready to shut down for the Christmas holidays. When you get back, you will have 11 days of classes to complete the final 2 units and prepare for your final exam, which will be on the 12th day after we return. Those are hard deadlines. If you do not complete the work or those exams, including the final exam, by the dates, then you will receive 0 and you run a real risk of not successfully completing Math 10C. So if you are behind, you're going to need to take your work home over the holidays and catch up. You don't want the semester to be spent in vain. You don't want to have wasted all that time. Anyway, I hope to see you soon. Take care.